Hello everybody, my name is Halo. Welcome back to the series where we're dealing with operating systems. In today's episode, we're going to be talking about the dynamic memory problem, which again is a very simple thing when you're trying to code it. We'll try to go over the concept also as quickly as we can, and we'll try to code out the ifs. So in this video, we'll be going to cover first fit, best fit, and worst fit, all three in the same video, because the code is very interrelated to each other. If you're able to understand one, you'll be able to understand the rest. Okay, let's talk about this dynamic memory problem. Okay, maybe my handwriting is very bad, I'm sorry guys. Okay, when you're talking with this problem, there's only two things you really need to know. One is something called as a workload, and then something called as a block. These are two things that you have to do. Okay, what is a workload? Workload is a resource request. These are processes which request some certain amount of RAM from you. Okay, what are blocks? Well, these are chunks of memory. Okay, so let's give an example with blocks. Okay, so let's say I have three blocks right here: block A, block B, and then block C. Okay, I have A, B, C. Let me just name the blocks and also assign them some memory value. Okay, so I'm going to give A, for example, let me just give A as 200. I'm going to give B as 150 and then C as 100. Okay, this is blocks. What is a workload then? Well, a workload is a queue of requests, resource requests. These are processes which need memory. Okay, so let me go ahead and get some processes for you. So let us say 150, 100, and then 120. These are three processes requesting some resources from the system. Now, what is the dynamic memory problem? Well, our task is to assign these processes into one of these memory chunks. Okay, so how do you do that? Well, there are three algorithms actually. Let's start with first fit. Okay, so what does first fit actually do? It assigns this resource request to the first available chunk. What does available mean? Well, for example, in this case, you can see that the process requires 150, right? Let's assume that's kilobytes or something like that. But A has 200. So A is available. So what I'll do, I'll assign this 150 to A. Okay. Then A will be remaining with 50. Okay. Then I have 100. What I'll do, A is not available now. What's the next first thing? B. Okay. So I'll assign this to B with 50 will be remaining. 100 will be assigned. So that will go down to B. Now I have this 120. You can see that A is not available. B is not available. C is also not available because C only has 100. So 120 can't fit. Now this is a problem. Okay, and why we can't fit this entirely? Well, we have to fragment this process now, put something in A, something in B, something in C. So our goal will be not to fragment, okay, as much as possible. Here in this case, using first fit, I can't fit this. Okay, now let me just erase all of these. We'll start the same problem with another algorithm. This algorithm will be called best fit. Okay, now what does best fit do? Well, it'll do the same thing essentially, but instead of me assigning to the first available memory block, I will assign it to the first block which has slightly larger memory than what I request. What does this look like? Well, let's come back to that. Okay, let's say my request is 150. Okay, in case 1, A, you can see that 200 is greater than 150, definitely. In case 2, B, 150 is greater than equal to 150, correct? We can do equal to 100 is not greater, right? So 150 is greater than 100. Therefore, I can't assign this to C. Definitely, that's something that we know already. But between A and B now, where I'll assign this is the least from which is greater than my request. So in this case, you see 150 is the least that is greater than my request. Therefore, I will assign this value of this 150 to B. 150 will be assigned to B. Okay, now let's come to 100. You can see this is assigned, this will become 0 now. I have 200 and I have C 100. Where will I send this? To C, because C is the least amount of memory which is greater than my request. Okay, so I'll assign this one to C. I'll set this to 0. Okay, finally when I get this 120, you can see that A is available. It has 200, right? I will just, and nothing else is available, so I'm going to go ahead and assign this 120 to A. So A will be remaining 80. I am able to fit everything. everything. And this is what best fit is. We have one more fitting algorithm. I'll just show that also, so that you guys can be able to understand. I hope you're able to understand what we're doing with first fit and best fit. Let's start with worst fit now. Worst fit. I'm going to erase all of this again so that you're not confused with these remaining things. Okay. Now, what I'm going to be doing here, see, I am going to assign this. So I told you in best fit, we're assigning this to the process with the least amount of memory, which is greater than whatever I'm requesting, right? In worst fit, I'm going to assign that to the most amount of memory, which is greater than whatever I have. Okay. In this case, 150 is there, correct? I have 200, 150, and 100. 100 though obviously I can't give because it's not available. But between 100, 200, and 150, in best fit, we assign this to 150, but in worst fit, I'm going to assign this to 200. So 200, from A, we'll assign this 150. So 150 will be going to A. A remaining 50. Second case, 100. I can assign this to either C or I can assign this to B. What I'm going to do, I am going to assign this to B and not C because I am doing worst fit, not best fit. Okay, I'm going to be assigning to the highest amount of memory available. Okay, so this 100 resource request will go to B. Now B will only have 50 remaining. Now when I have C, right, you can see that none of these are available. Therefore, I can't fit this 120 again. Can't fit. So in this case, we are not able to fit in first fit and worst fit, but we are able to fit everything in best fit. Now, in looking at a normal case, right, I've picked this out, cherry picked this case alone to show you that only best fit fits and first fit and worst fit does not fit. In an ideal scenario, this won't be the case. In most cases, first fit, best fit, and worst fit can fit sometimes. Sometimes first fit might fit, sometimes worst fit alone might fit. So why do we have three algorithms? Why don't we do best fit always? Well, let's talk about this. Okay, first of all, first fit is actually very, very fast, right? In best fit, we are trying to figure out, right, which is the lowest amount, and then from there we are assigning. In this case, you only have 3 blocks and we only have this many requests. But if let's say we have hundreds of thousands of requests and many blocks, right, hundreds or thousands or even 10,000s of blocks, in that case, going with best fit and trying to figure this out every time takes a long time. So if I'm able to do this via first fit, I'm able to achieve this fast. Best fit is used for efficient space usage. Okay, that is where best fit comes in, and that's why we're trying to do this extra work. Okay, now you can ask me, why do I need this worst fit at all? Well, actually, why you need worst fit is we are allocating to the biggest blocks so that there are larger chunks for future use. In best fit, there is less wastage now, but it leaves behind these tiny gaps, right? But in worst fit, what happens? It actually leaves behind a lot of gaps so that in the future, if there are processes slightly exceeding that, I can always allocate that. Okay, so that is what the scenario is. Okay, so let's say you have processes of varying unpredictable sizes. Okay, so you have some few small processes now, but you might expect these large processes later. If you use best fit, you might break these big blocks into these crumbs, and then when the big process arrives, there is no fit left, right? Worst fit avoids that by making the block preserve as much as possible. For example, even let's say here, instead I'm getting this request for 50. Okay, I'm going to be assigning this to 200. That's what worst fit that, which means I have 150 left. Correct. So in the future, if I'm able to get these processes, I have big holes left behind, so I'm able to accommodate that. That's why worst fit exists. I don't know if I did the best job explaining that. Maybe you can work around and look at other sources also, but I am not a theory YouTuber. I am trying to get all of this into code. So if we're able to understand what we're doing in first fit, best fit, and worst fit, you are good to go. Let's go ahead and see what this looks like in Python. If you understood it to a great extent, I'd actually recommend to do it yourself. If not, let's go ahead and see what that looks like. Now, first of all, let's go ahead and define what our blocks will look like. So blocks will actually be a list, and this will be a nested list actually. So A will be 200, I think that's what we told. And then B will be something like 150, and then C will be 100. Yeah, this is what we gave. And similarly, we have a workload also, right? This workload will be in our case 150, 100, and then 120. Okay, this is what we're going to fit into a lot of these things. So let's go ahead and define different functions for all of that. Let's start with first fit. Now, let me just go ahead. So this is the logic that we're going to be using in order to do this. This is what we just discussed. In first fit, we're going to be searching for the first available slot. In the best fit, we'll search for the smallest available slot. In worst fit, we'll search for the largest available slot. Okay, so let's start with first fit. So here, let's take two inputs. One will be the blocks itself, and then we'll have the workload also. From there, let's go ahead and see assignment will be the a list, and there'll be a list for can't fit also. This will be process that we're not able to fit. Okay, so what we will do is while this workload, which is a list that is not empty, while workload is not empty, what we will do is we will go ahead and pop the first element. Okay, so workload dot pop of 0, we get the first size of that particular process. So initially, let's say a flag and say that the assigned is equal to false. For I in blocks, what we're going to check, so I of 1 will be the memory available. Okay, so what I'll do is if the size of my current process is lesser than equal to I of 1, that is, it is available, in that case what I'll do is I'll actually subtract the size of I of 1 with the size of my process right here. Then what I'll do is in this assignment list where we're assigning all of this stuff, I'm going to go ahead and append I of 0, which is the block that we're assigning this to, along with the size that I'm just assigning. So size will be nothing but the process size that I'm just assigning. In this case, assign will be true, and I can just break through this for loop, right? And then we can just break through this for loop, and then I can actually say something if the size that it is not assigned, and that is why we have this flag right here. What I'm going to do is I'm going to append this to can't fit dot append size. Okay, and then this will keep going on till the workload is empty. So there are two loops here. This loop, that's why we're breaking through once it's assigned. Okay, so once you've done with the following, we can actually just print all of this. So you can say assigned the following, and then we can just print the assignment itself. Okay, so if the can't fit list, if that is not empty, what I will do is I will just print couldn't fit the following, and I will just go ahead and print this list also to the user. Okay, now if you're able to understand what we are doing here, the next two things will become so easy for you that you'll be able to code the rest in 30 seconds or so. Okay, so for best fit, I'm saying here that search for the smallest available slot goes to allocation, and blocks are the available slots. When I want to search for the smallest available slot, what I will do is I will sort my blocks in ascending order. And if I'm able to do that, whenever I have, for example, say this workload is there and this is in ascending order, it'll be C, B, and A. In that case, what will happen is this will always, when you're iterating this, it will choose for the smallest available slot. That is the beauty of this. So I can just copy this code over here, paste this below, change this to best fit. Okay, and below here, when I'm searching for the blocks, what I will do is I will always sort these blocks in ascending order, so that whenever I'm assigning this, right, I'm always able to assign this to the smallest available block. That is why I'm doing this in ascending order. So I'm just going to do sorted, and I'll take my blocks as an input, and then for the key I'll take lambda function. I'll just sort this using x of 1. Okay, that is nothing but this one right here. If you're able to understand that, great. Now if you're able to understand this, I think something that you can piece together in your mind is for worst fit, I just need to do the same in reverse. So in worst fit, I'm going to look at the largest available slot which is there, and for that I should always sort this in reverse order and iterate through that and assign it to the most available slot, right? So I just change this over here. I'll just paste this back. I'll change this to worst fit, and instead of here I will actually change this to the reverse value. Okay, so in order to do that, we add one more line here. We just will reverse this list. Okay, so blocks will now be equal to blocks of, just give two colons and then -1, so that we just reverse the list right there, and then let me just iterate through the list. The rest of this will remain the same. So this is actually the dynamic allocation problem. I'm going to go ahead and write the driver code so that we can go ahead and test how all of this will look like. Now, one problem that I do have is I can't assign this directly to all three cases because that will be just shallow copying this list and everything will just get modified from here. So I'll just change this to workload 1 and blocks 1, and then I'll do the same thing here. And so that I'm able to just pass this, and I call this workload 2, and then blocks 2, and then workload 3, and then blocks 3. Okay, so here let me just print first fit, and then I just go ahead and run this in the first fit function with the blocks 1 and then workload 1. And similarly, I will just copy and paste this below 2 times so that I'm able to do the same thing again. So this will go here, and then this will go here. Okay, so this will be best fit, and then this will be worst fit. And this will just be blocks 2, workload 2, and then this will be blocks 3, and then workload 3. So let's just modify this also to say best fit, and then this will be worst fit. Right? If once this is done, let me just go ahead and run the code. You can see that it is assigned stuff. So first fit, assign the following 150 and 100. Yeah, that is something that we are not able to assign this. In the second case, we're able to assign all of that, B 150, C 100, and A 120. Worst case, again, we're not able to assign all of that. When we check this again with our code over here, you can see in first case 150A, 100B, and then this is also 150A, 100B. In second cases, B will be 150, C 100, 150, 100, and 120A. And similarly, 120 can't be fit, 150 will be A, and then 100 will be B. So that is what worst fit also looks like. So this is the dynamic memory problem. I hope you're able to understand what we're talking about in this video. If you were, that's great. Hit that like button. Thank you so much for watching this video. If you have any questions, let me know down in the comments. I'll try my best to answer them. I'll see you in another video. Until then, bye.